Hello, you're welcome back. Okay, so now we are going to be looking at force and motion. So basically, we'll look at the relationship between force and motion. And the person that actually studies this relationship is Isaac Newton. Okay, he was able to establish the relationship between force and motion by his laws of motion. So now we're going to be studying Isaac Newton laws of motion. Okay, so now Isaac Newton actually stated three laws of motion. Okay, so we're gonna be taking the one after the other. So we'll start with the very first law. Okay, first law. All right. So according to the first law of motion, okay, Isaac Newton makes us to understand that a body continues to be at rest or in a state of uniform motion unless it is being acted upon by an external force. Okay, so I could actually bring that up here. So this first law, uh, here we go. First law states that a body continues to be at rest or in a state of uniform motion unless it is being acted upon by an external force. Now, this Newton first law actually describes the principle of inertia. Now, what is inertia? Inertia, right? Now, inertia is the reluctance of a body to start or stop uniform motion. All right. So now you could actually notice, of course, we said that the first law, okay, is a law that actually describes inertia. And we say inertia is the reluctance, the word reluctance. Okay, when something actually have a reluctance over a thing or over something, it reluctance is simply the unwillingness or delay. Okay, so the unwillingness to actually do a thing, that's reluctance. So now, and inertia is the reluctance, okay, of a body to start or stop uniform motion. So what simply means that if this body is already on a motion, in a motion, let's take for example a car moving at a very high speed. Okay, when this car is actually stopped, let's say you apply the brake here to stop this car at this particular point, the car cannot actually stop here. Why? Because there's going to be a kind of reluctance that will cause the car to accelerate to some distance before it actually stops. That is why if you want to stop a moving vehicle, okay, you have to stop applying the brake on time before you actually finally put it to rest. Why? Because every motion, okay, possesses a reluctance, and that reluctance is what you also see when the object want to move. Okay, there is this unwillingness, okay, to actually start motion or even to stop motion. That is what reluctance is. So please take note of that. Now let's look at Newton's second law. Now Newton's second law states that the rate of change in momentum is directly proportional to the applied force. Okay, the rate of change in momentum is directly proportional to applied force. Now for us to understand this, we should actually first ask ourselves, what is momentum, right? In physics. Now in physics, momentum is actually a product of mass and velocity. Okay, the product of mass and velocity. So, and it's a vector quantity. So anytime you hear of momentum in physics, okay, momentum is actually the product of mass okay, it's mass times velocity. So according to Newton's law, he says that the rate of change in momentum is proportional to the applied force. So since we already know that momentum is mass times velocity, so if there's a change in momentum, that simply means that there's a change in velocity. Okay, so change in momentum is simply going to be equal to Okay, when there's a change, that means that there was initial and final. So that simply means that I'm gonna subtract the final momentum minus the initial momentum. That's a change. Change in mathematics is actually difference, right? Final minus initial. Now, let the final momentum, okay? The final momentum is mass times the final velocity, while the initial momentum is going to be mass times initial velocity. Okay, so that change now in momentum, okay, is now going to be mv minus mu. Now, as you notice here, m is actually a common factor. So I factorize it and open a bracket. So m is a common factor, so I now have to put the other factors inside the bracket, which of course is v minus u. So anytime, okay, we actually talked about change in momentum, okay, it's simply going to be change in momentum is simply equal to mass multiplied by change in velocity v minus u. Okay, so please take note of that. So let's now relate it to Newton's second law. According to Newton's second law, he says that, okay, this change in momentum is proportional to the applied force. That means the force applied is actually equal to the change in momentum. The rate of change in momentum. The rate of change in momentum is proportional to the applied force. Okay, and the rate in mathematics is always with respect to time. Whenever you're expressing a quantity based on rate, okay, you are dividing that quantity by time. So the rate of change in momentum is something as change in momentum then divided by time. So it's proportional to the applied force. All right, so invariably it's equal to, that means the constant of proportionality is 1. So now just this formula here is a formula that we get from Newton second law, and it is this formula that actually gives us the relationship, okay, between force and of course change in momentum. So from Newton's second law, we have gotten the very first formula for force. So force is actually giving us change in momentum mv minus u divided by time. It's very important. So that's one way of evaluating for example, okay, if an object, okay, if I have an object of mass, let's say 2 kg, okay, is let's say the object is actually moving with an initial velocity of the object start from rest, move an initial velocity of, okay, from rest is initial velocity is equal to 0, then it now move with a final velocity of 10 meters per second. Okay, so if you are being asked to evaluate the force on this object within 2 seconds, simple, okay, that's going to be equal to F is going to be equal to mass 2 bracket open final velocity, which of course is 10, minus the initial velocity, which is 0, then divided by the time 2. So this will be 10 Newton. All right, so please take note of that. Now this is one formula for force. I'm going to also, okay, derive another formula for force here, right? This is going to be mass times, force is mass times v minus u all over t. V minus u all over t, right? Now v minus t u all over t, when we treated linear motion, v minus u all over t, change in velocity with time divided by time is always acceleration. Acceleration is always change in velocity, okay, with time. So that means force can also be given as mass times acceleration. So let me call this formula number 2. It's either we express force as change in momentum all over time, or we express force as mass times acceleration. So that is number 2 formula, okay, for force. So that is why we can actually, Newton actually describe force as a push or a pull. So force is that quantity that when you actually apply it on an object, okay, it will cause that object to do what? To accelerate. So when you apply a force on an object of mass m, it will cause that object to accelerate. So it's a push or a pull. All right. So now let me clean up. I still need to derive another formula from what we have before. Force is equal to change in momentum divided by time. If I should cross multiply, okay, if I cross multiply, I'm gonna have change in momentum, mv minus u multiplied by 1. That's gonna be change in momentum, right? Then f multiplied by t, that's ft. Already we know that this right hand side here is actually the change in momentum. Okay, so now the left hand side, please pardon me, the left hand side is already changing momentum, but the right hand side, force times time. Force times time, the product of force and time in physics is known as impulse. Okay, impulse is the instantaneous force an object, the force object experience at an instant, instantaneous force. So that means in physics we can simply say that the change in momentum of an object is equal to the impulse on that object. So when there's an instantaneous force, when there's an impulse on an object, it will cause that object to change momentum. Okay, so please take note of that. So invariably, if you are being asked to evaluate change in momentum, okay, you are also evaluating impulse. So what's the SI unit of change in momentum or impulse? The SI unit of impulse is Newton seconds. Why? Because the SI unit of force is Newton and the SI unit of time is seconds. So that means SI unit of momentum is also what? Newton per seconds. Newton seconds, please pardon me. Okay, so please take note of that. For example, if I have a mass 2 kg, okay, let's say that mass is already moving with an initial velocity of 20 meters per second. Then it actually hits a wall. It hits a wall, then it now returns back with a velocity of 10 meters per second. So the question is evaluate the impulse. Okay, now impulse. According to what we have here, the impulse on that particular body is still equal to the change in momentum. And the change in momentum is also giving us mv minus u. But one thing is very important for us to note. Remember when okay, this final velocity was a rebound. Anytime the question comes in this way, where the object hits a wall and returns back in the opposite direction, okay, then that simply means that the minus here becomes plus. Okay, why? Because both the initial and the final is now in the same direction. Okay, so the minus there becomes plus. So in a case like that, now that's going to be equal to the m is 2 kg, open bracket, the final velocity is 10 meters per second. All right, then plus the initial velocity, which is 20. So this is gonna give me 2 times 10 plus 20, that's 30. 2 times 30, and that's gonna be 60. Remember, there's how you need Newton seconds. All right, so we are going to look at Newton third law. All right, and that will be in the next video. Okay, see you in the next video. Thank you very much.